Hello there, this is Abdullah. In this week video, I shall discuss the security and privacy risks associated with wireless sensor network. During the last week, I had covered a case study on wireless sensor network that was used to monitor buildings in cultural heritage site. I'll first explain various privacy and security risks in this network. Following this, I will talk about strategies to overcome these risks. First of all, let me recap the case study discussed last week. A wireless sensor network was deployed at UNESCO Cultural Heritage Site in Italy in order to monitor climate conditions such as temperature, humidity, and heavy rain. This case study was conducted for a period of 55 days, and the result showed a weakened structural integrity by exactly measuring masonry cracks in the building. As self-powered sensors were used in this case study, it requires battery change at regular intervals. If this is not done regularly, the sensor will fail to collect and provide critical data to the network, thereby putting the security of the building at risk. In this wireless sensor network, sensors monitor specific change in the building condition and report to the base station, also known as the SING. Since a wireless network is prone to security risk, the data being transferred across the network can be altered or spoofed, known as spoof attack. As sensor nodes typically have a short transmission range and low processing power, an attacker with higher processor can attack sensor network. Attackers use various strategies to monitor, interrupt, and modify the flow of traffic in network in order to provide wrong information to the base station. For instance, a sensor node can be made to forget the identity of other nodes to degrade integrity of the data, which is known as spy attack. When an attacker floods the sensor nodes with hello packets, it tracks the network into believe that the attacking node is legitimate sensor node. When an attacker delivers data packets received in one part of the network to another part of the network through low latency, it creates vulnerabilities that compromise data integrity. In sinkhole attack, malicious nodes act like a sink that tracks all network traffic. Encryption requires additional data to be transmitted, which requires additional processing power and power, as wireless sensor networks are limited in processing power and battery life. It becomes hard to encrypt data. Encryption can also introduce packet delay and data loss to a wireless sensor network, which is not discernible in application that requires accuracy and precision. As a result of this compromise, critical data in wireless sensor network may be interrupted by hackers with more processing power. When a sensor network privacy is compromised, the data is being monitored may end up in the wrong hands. This breach of that data may actually compromise the security of the heritage site being monitored by the sensor network. It is important to have stronger methods of authentication to secure sensor wireless network. For instance, reward routing algorithms use different security measures for traffic from different sensors. Location in order to flight vulnerable attacks. Similarly, TinySec and SNAP protocols improve data authentication in the network. A dense sensor network with a large number of sensors will also make it possible to discard spoofed data packets. Similarly, in a distributed sensor network, it would be possible to add and remove sensors from the network as needed, while proxy-based filtering discards dummy messages, tree-based filtering organize nodes into heritage based on their closeness to the base station. As a holistic approach to security, it's necessary to secure wireless sensor network. Apart from using different security schemes to secure various layers, it's also important to secure the physical sensor from tampering. However, it's also important to focus on energy efficiency and cost effectiveness while securing various layers of sensor network. Improving protocol for battery saving is also necessary to enhance overall quality of monitoring. Finally, developing a data-centric sensor has the potential to be secure from various attacks since the data will be stored in random location in the sensor network. As a high-security key management scheme will be in place, the attacker will not be able to determine the future location of where the data will be stored. These are some of the resources that I used to create this video. Do let me know if you have any question in the comment section. Thanks for watching.